we needed transparency, we needed explainability, we needed to understand the chain of cognition associated to how we operated with AI, if it was going to catch any sort of traction in the environments that we used to work in. Zero tolerance to failure, defense, intelligence, energy, finance, healthcare.
Welcome to the Talking AI podcast, where we talk AI with both experts in the field and early adopters. I'm your host, Matt Paige, and we're here to demystify AI for you so you can get some value from it. Let's talk some AI. Hallucinations and trust issues continue to be a major roadblock for AI adoption. What if the results from AI could actually be explainable? And that's exactly what we're going to get into today with a couple of really smart guys from data². We're joined by Jon Brewton, the founder and CEO, bringing deep expertise from energy and government sectors, and Daniel Bukowski, the CTO, whose impressive resume. You got like Facebook, Microsoft, Robinhood, Neo4j, which gets really deep into the graph side of things, but excited to have you guys on the podcast. Welcome.
Thanks so much, man. I really appreciate it and look forward to the conversation today.
Yeah, it's going to be fun. So, Jon, kick us off. Just give some context for who data² is.
Sure.
Just to kind of set the stage, and then leading into Dan, we'll get into some of the what is a graph database? How does it differ from relational databases, LLMs, all that kind of stuff?
Sure. Well, look, we started data² in sort of mid 2023, leading up to September 2023. I was leading a company in Australia that was a bespoke analytics consultancy, really building solutions, machine learning and AI solutions at scale for a lot of folks in the Australia and New Zealand region. I had left Chevron after several years in the oil and gas industry. And throughout that sort of time at Chevron, we spent a lot of time trying to optimize how we work and how efficient we could be as an organization with just the interactions that we had with the technology that we had on, and then trying to find new solutions that we can incorporate from a commercial perspective that would change our ability to sort of go further up the efficiency horizon and make sure that we can get as much blood out of the stone as we could. And I called one of my old buddies that I used to work with at Chevron, a guy named Jeff Dogley, and said, "Hey man, it would be really interesting to see if we could figure out how to use this technology with the tools that we knew from the past and see if we can do anything novel and interesting with them." And we found pretty quickly that it worked exceptionally well. And when we presented a graphical construct to a large language model, it not only understood it, it fundamentally could crawl the connective tissue between any one entity or any relationship within the structure of the data that we presented it. So we thought, wow, we might be onto something. It brings a real commercial focus to what we're doing. We said, all right, let's start a company. Let's see what we can do with this new technology. But we started it within the context of high reliability organizations and high reliability operations, which meant we needed transparency, we needed explainability, we needed to understand the chain of cognition associated to how we operated with AI, just in general, if it was going to catch any sort of traction in the environments that we used to work in. Very specifically, high reliability industry can be defined as sort of a zero tolerance to failure, defense, intelligence, energy, finance, healthcare, all sort of subsegments of this environment. But the thing that really gave us an opportunity to figure this stuff out was an initial pilot test we did with some intelligence data. We got accepted into a Catalyst Accelerator program with the US government and the Air Force Research Labs. And we started looking at intelligence and all source intelligence as a play within the structure of what we built. And at the end of the day, we built this modular, cloud-agnostic, zero trust secured platform. It's an AI solutions development platform that gives us the ability to step away from traditional black box applications and step into an environment where we can create traceable, transparent, and explainable outcomes. And that's really where sort of Dan's expertise starts to hit the environment, because he comes from a background that understands this space really, really well.
Yeah, and that's a great intro. I'm excited actually to get into some of your experience with some of those more regulated industries in a bit. 'Cause like that's a whole nother ball
Yeah.
game, I'm sure. But Dan, like let's awesome intro, really cool perspective. But I'm sure some people are like, okay, well, what makes y'all unique in a sense, and what is this whole, you mentioned knowledge graph what is that? And what are the components that are coming together? You mentioned with this like Gen AI, Chat
Mhm.
GPT moment that's making this unique opportunity right now.
No, definitely. And I've been working with graphs for 20 years. I started my career as an accountant and an intelligence analyst 20 years ago
That's a
in the
good
federal
mix.
government. So I was building graphs by hand to do follow the money investigations.
Uh,
So if you think about a graph, you have the entities, the nodes, and the relationships, which is how they're connected. And a real easy way to think about it is the nodes are the nouns in your data. If you John will bring up a graph here in a little bit, and we'll take a look. But it's the people, the places, the things, the ideas. You know, Dan could be a node, John could be a node.
mm,
Then you have the relationships, and so that's how everything is connected, and that's really the secret and the essence of a knowledge graph is it tells you how the things in your data are related to each other. So if you have a spreadsheet of accounting information or financial transactions, which is what I used to work with, when you're looking at it in a Microsoft Excel and rows and columns, it might not look like that data is connected, but it actually is
mhm.
because you have money being sent from one account to another account. You just can't see it in the spreadsheet format. Similar to when I was working at, you mentioned Microsoft and Facebook doing IT security, security engineering, we would have millions, if not billions of rows of IT logs, which were really similar. You have one IP address connecting to another IP address, transmitting data or accessing a certain service. When you're looking at that at a spreadsheet, you really can't tell how things are connected, even though the data does contain connections. And
Mhm.
so that's what a graph allows you to do. We built on the Neo4j knowledge graph. I used to work there. It's also the original graph database. And so we believe it's, the industry leader at this point and why we're building on it. So when you bring that data together, what you get is, at the database level, so written to the database, you have the things, the nodes in your data, as well as the relationships of how they are connected. And this is really important when you're an intelligence analyst or any user of the database, because if you're dealing with relational, you might have 3 or 4 tables that you have to do a join on to bring things together to show how they're
Yep.
connected. That could take 30 seconds. That could take 30 hours, depending on the volume of the data. But when you're working with a knowledge graph, all of those connections already exist. They've been written to the database. And so, what that practically means for an end user is instead of waiting 30 hours to do 5 different joins of the table, which as an end user, I have no idea what's going on under the hood. I probably
Mhm.
don't even care. All I know is it's taking me 3 hours or 30 hours to get my data. But if I have that data in a graph, it's much easier to visualize how it's connected, but then also to get that information when I need it. And so that's why we're building on the foundation of a knowledge graph with some additional technologies that John mentioned and we can get into as well.
And that's what it almost feels like it gives your data like
It
dimensionality, like
does.
depth to it in a sense. It's like you're going from this, it's like Super Mario Brothers to, name your video game with the the 3D world and whatnot.
Yeah.
It
There's a
really
great
does.
Yeah, I
Go
was
ahead,
gonna
John.
say there's this great old book that Jeff talks about all the time called Leaving Flatland, which was sort of the conceptual,
Yeah.
theoretical application of moving from sort of 2D systems and understanding of information to just a three-dimensional representation of that information. Like, Dan's probably going to talk about this in a slightly different way, but as an engineer and looking at things, maybe he'll talk about it the exact same way I'm about to say it, but traditional systems and people see rows and columns. They see disconnected rows and
Mhm.
columns. And what we're really gearing toward is building a vast, really contextualized three-dimensional landscape that we can present in that format to a system so that it inherently understands the connective tissue, not only between the pieces of this puzzle, but how it can transverse that information environment to get to all of the information components
Yeah.
relative to a given query. I mean, this really is about taking things from 2D to 3D in concept.
And so, like, let's take it to the next step because I'm sure there's some people that are going that may be familiar with kind of a knowledge graph and this technology going, okay, well, is this like something I'm using instead of a large language model? Is this new different
Yeah.
thing? But it's not. They're complementary in nature. I think this is where it starts to become differentiated. But like just a story from back in my day, I used to work with a team of data scientists, and we'd get all these requests, or if the business needed a request, they put something, they do a ticket. Whoever's creating the thing, they'd write the SQL query, they'd return the results. That would
Yeah.
trigger another question. Then you'd have to get back in the queue. And it's just this like really painful
It is.
back and forth. But I'm curious, either Dan or John, whoever wants to take this, what happens when you put an LLM with this knowledge graph?
No, and that's something that we've seen over the past few years. So when I joined Neo4j, my background's data science. My technical background is data science as well. And when I joined Neo, it was to focus on using algorithms, help customers
Mhm.
use page rank and degree centrality and these algorithms that were designed specifically towards graphs. Well, then about 6 months later, ChatGPT was released, and kind of the technology world was turned on its head with new capability.
Hmm.
And what we were hypothesizing, and then has eventually been proven out by not just Neo, but also Microsoft, Google, BlackRock, all kinds of other research papers and kind of publications, is that the traditional way that people are currently working with language models right now for providing them with that additional information that they need, the retrieval augmented generation or RAG, is to take unstructured data, so PDFs, presentations, text, chunk it up, and then put it into a vector database, which is
Yep.
designed to handle that specific type of data. What we've seen quite a bit, I saw it when I was at Neo, we're seeing it here, is that that's a quick and easy way to get started providing the language models with that additional information they not have, your company's policies, your company's data, research, or whatever. But they really can't get beyond that 60 to 80% accuracy. It's almost like that ceiling that you just can't break through. And the challenge with that is it makes it unreliable to put that into production, especially high reliability, as John was mentioning, or customer facing production. There are those use cases, what is it, a year, 2 years ago, where the state of New York had an issue with a lot of inaccuracy, some kind of embarrassing stuff with Air Canada. There
Airline,
was like
the
someone got,
selling
yeah,
the car. Yeah. Yeah. There's
yeah,
a
they
lot of
were
good ones
selling,
out there.
flights for free, and that's
I'm
a
surprised we
problem.
haven't seen more of those crazy use
Yeah,
cases, to be
I
honest. Like,
know.
I'm surprised there's not. I feel like with the AI agents and operator coming out, we're
Yeah.
about to see more. But sorry to like
Oh, no.
break
Oh
out
I
there.
no.
think honestly what it did was it gave everyone pause of like, I am not going to put this in production or
Yeah.
customer facing production
Yeah.
till I know sure it's accurate. Well,
Hmm.
that's where graphs come into play. And what we've seen through, the research and the experimentation and kind of really what we're building around is graphs provide more explainable and more contextual information to the language model than just the vector store, like the chunks of data. And
Hmm.
what that means is the traditional approach to RAG is where you're just querying a vector store. What it's doing, it's scattershotting the information to the LLM. Here's 10 pieces of information. Use it to answer the question and have fun figuring out how it all goes together. It might be related, it might not be related. I'm just going to throw some pages of a book at you and read it, figure it out, come up with an answer.
Yeah.
That kind of work to get you to that 60 or 80%, but it's going to really struggle to get you to that, upper 90% reliability that you need to put it into production. What a graph does is it says, here's the pieces of information, but here's how the pieces of the puzzle fit together. So think of it, actually, really, I'm on the fly. I could either be throwing a bunch of pieces of a puzzle at you and saying, figure it out, or I can put the pieces of the puzzle together and hand it to you on a platter and say, here's the big picture that we're getting to, read it and analyze it and use it to answer the question. And yes, I did just come up with that on the fly.
Yeah.
I'm picturing
Um,
you like throwing
That's
a box of puzzle pieces
yeah,
at
like
John
ninja
is what I'm
stars.
visualizing right now. Yeah,
Yeah.
exactly. Yeah,
exactly.
I'm
Yeah.
sitting here
Yeah.
ninja throwing it at you. So,
Wait, so with I'm going to take this opportunity to learn while I got some smart people who got their attention. But like when you get the vector database, the whole concept there is like you talk about like nearest neighbor,
mhm.
in essence. So like, but
The
in I'm
mathematical
starting
proxy,
to
right?
yeah. So what and you're getting to this, Daniel, but like, where does it differ with the graph? And if it gets too technical, just tell me and I'll go chat GPT after with the,
At a high
off the
level,
phone.
so it's interesting. Graphs are unique in that they don't really have a starting point in a sense. Looking at a spreadsheet, you have cell A1. You kind of know where you're
Yeah.
starting, typically top to bottom, left to right. With a graph, it's you can really start anywhere. And so the key is, the key with we'll call this the retriever, how I'm querying and retrieving the information is where do I want to start? Where am I going to anchor? And then how am I going to traverse the graph? So I can really start anywhere. And that's part of what we're building. And that's some of the technology that's built into Neo4j as well.
Mhm.
Um, you mentioned the traditional vector search, kind of vector, nearest neighbors, approximate nearest neighbors,
Yeah.
similarity. That's a great place to start. Like that works. You can use that. We use that for some of the data in our platform. That's
Mhm.
what you use. We use vector stores as well because while they will only get you so far, they do have their purpose as part of the
Mm.
whole application. And so those typically work for unstructured information. So if you
Gotcha.
have text or PowerPoints or, kind of the data that doesn't fit into rows and columns. But what we also do is translating the query into Cypher, which is the Neo4j query language, I think SQL, but built for graphs. And so that will help you actually find a better or maybe a different starting point than just simple similarity search. And so you might traverse to a different part of the graph and then query the local nodes and relationships or follow a specific path. And what we're doing is bringing all of that data together. You might have nearest neighbor search that brings you this piece of information. And then you might have a text to cipher query that's going to bring you other information from the graph that all have their place in generating the response.
Yeah.
And that actually highlights another benefit of the graph in that graphs do really well combining structured and unstructured information versus a
Mm.
vector store alone or vector only RAG, which is really you can work with structured information, but it really does its best work with unstructured information. So text
Gotcha.
documents
That's right.
um, and
So
so
they
we're
they
bringing all
complement
of
each
that.
other in
They
some
do.
ways. They're not
Absolutely.
necessarily alternatives. Okay.
Yeah.
Yeah,
I,
it's not
That's
an
very
either
helpful.
or. It's bring it together, and
Yeah.
that's what we're
Yeah.
building. We're building that application layer on top of it that it does a lot of things, but one of them is bringing all of these pieces together in a solution on top
Yeah.
of multiple database types.
yeah.
Okay.
Yeah, you have to, like, from our perspective, you have to understand when we're talking about target market approach, we're looking at environments where 95% is actually not a good enough answer. And so
Mhm.
you have to understand the different things you can throw at this, the fidelity of the information you need to store or have to store, where it traditionally resides. As I said earlier, like everybody sees the world in rows and columns, but when you're using things like vectors, you're essentially coming up with I think these two things are related within this context. And what we're
Mhm.
doing from a graphical perspective is saying, we know these two things are related and here's
Yeah.
why. And so that's really the departure. So one thing works pretty well on getting a roundabout answer. The other one is imperative if you want clear, transparent, and explainable answers.
See, and that's great. Y'all aren't just engineers. You get some business acumen as well, because you're taking like this. Okay, who need this very accurate
Yeah.
approach when you're leveraging AI? Well, government, energy, the ones you mentioned. So it's a great
Mhm.
kind of like niche to focus in on, and that's where
Yeah.
like the value is. Like we hit on earlier, hallucinations are one of those key things that is stopping a lot of AI adoption. This helps you combat that, and it gets to this whole idea that I see so many people, they run into an issue with AI. They're like, "Oh, it's cool. It's just kind of a nice toy," and they forget it. But it's this evolution we're going to see of how solutions are architected, the applications that begin to emerge that are going to make it this, just amazing kind of new world that we're not ready for. I equate it back to like the beginning of the internet.
Mhm.
You couldn't be on the phone and use the internet at the same time, and look where we are now. But talking about like the application, I'd be curious, like, are y'all up for pulling it up? Just because I think what's so cool about the solution is actually visually seeing like
Mhm.
how these nodes look. And we don't have to go super deep. And for those that are listening only on the podcast, we will be very, very descriptive.
I'll start
Yeah.
as John's bringing that up. I'll just our application is called Review, and I guess I'll anchor it on, there's three things that we're building it to accomplish. Yeah, as Jon brings this up, the first is helping you get your data into that graph form, because while graphs have been around for like several hundred years, and graph databases for, I believe, 15 going on almost 20 years, it's still a little niche. And
Yeah.
so that process of getting your data, whether it's rows and columns or unstructured data, into the graph can be challenging. And so we're accelerating that. The second is providing the user interface that Jon is showing here, so you can interact and get those graph-based insights without having to run Cypher queries, or kind of, you mentioned that process. You submit a ticket, someone runs the query, you get the data, you submit another ticket. We just want to avoid all of that. Let you interact with the graph and build upon what Neo has with some additional features and tools. And then the third part will be the natural language interface that Jon will show as well, where you can just
Mhm.
query it and have it perform tasks and work with you through that natural language interface without having to do it yourself. And so, yeah, Jon, as
And
Jon's
that's a
Yeah,
showing
big
here,
piece. And like for those
it's
that are
huge.
listening, what we're looking at is like some stats in this like web of just like interconnected nodes and things and all of them connect. But Jon, give us like just a quick like overview, because this is really cool.
Yeah, and so I'll table set this because it's a really interesting use case and one that kind of pointed us towards, oh, we might have built something that's hyper scalable. We had built a solution around an oil and gas problem, which I mentioned earlier, and we got it accepted
Hmm.
in this Catalyst Accelerator program. We had to do something DoD and intelligence focused. So we reached out to somebody in network and they gave us the capstone project that graduating analysts that go into the CIA, FBI, DHS do before they get into their full position within these organizations. Now, normally the team composition is 6 analysts, takes 6 weeks. The average score, because this is really differentiated data, is around 70%. If you've ever seen that meme of Charlie from It's Always Sunny in Philadelphia on the whiteboard with all the yarn
Yeah.
connecting everything, like that's what
That's a
these analysts are
great show, by
doing.
the way. Like this is
Fantastic.
completely
Yeah.
off topic, but I've watched it a
Yeah.
little bit back in the day, and my wife and I just like complete show hole, no idea what to watch. So we
Yeah.
started going back to Always Sunny in Philadelphia. It's just a really funny show.
yeah,
It's an
But
incredibly
sorry.
funny show. But that episode very specifically just is
Yeah.
a perfect proxy for what these analysts were working through. They were trying to connect human intelligence, signals intelligence, financial intelligence. This
Mm.
is in reports. This is in transactional data. We're talking about unstructured and structured information across a wide geographic region in the Middle East to understand a couple of key things. One, who's responsible for the killing of our confidential informant? Who financed it? And ultimately, are they planning any other attacks? And is there any
Wow.
incremental evidence within the structure of this data environment that leads to another risk being identified, one from a cyber perspective, which we unearthed. So we get this case study of information and we start looking at, a total evidentiary environment of 1,629 documents and spreadsheets.
Mhm.
It's a huge amount of information to crawl through. And so we have these human intelligence reports, these signal intelligence reports, the FINET. And so we have all this transactional density. And what we do whenever we ingest this information is we create a graphical representation of it. We define the entities, we define the relationships within the structure of those entities. So what you're seeing from a graph model perspective on the screen right now is this hyper contextualized reality of this information environment. So it's not only the constituent parts of that environment, it's how they're connected and the strength and density of those connections. And whenever you
Mm.
can see this stuff, to Dan's earlier point, whenever we present it in this context to a large language model, the model's ability to say, okay, I understand fully what you're showing me, how it's connected, why it's connected together, reduces model drift and answer drift almost explicitly. Now, we do some things that are proprietary to us to make sure that we can narrow that to almost zero. Like traditional
Yeah.
graph RAG
Wow.
applications that get you anywhere from like 80 to 92%. We're operating closer to that 98, 99% space. But it's how we do some of the proprietary stuff we do to enrich these environments and contextualize these environments. So on the screen, you see this like, here's this known entity. we can infer right away that this known entity is very, very important within the structure of this overall map because of how
And for
much transactional density you see coming
yes.
to and from every other piece of this equation.
And for the listening audience, this known entity has about 1,000,000 arrows just,
Yeah.
like, pointing right at us. But
And
Yeah.
that's
and
cool.
that's the
That's the
thing.
density component you're talking about, right?
Yeah, and this isn't even the actual data. What John's showing here is just the design of the model.
That's
You would
right.
think of it as the overall schema. This is, and that's why it looks a little bit like a hairball because you design the schema of a graph to be functional. It doesn't always present well, but
Yeah, yeah.
you can see conceptually how are things connected, and then as the data gets loaded, it's in these different nodes or relationships in the graph.
Yeah.
And then the
Now,
next cool thing is you can actually ask it questions and chat with it. Not that we have to go into
well,
demo of that, but that's the cool thing. You don't have to necessarily write all these complex queries
that's
necessarily
right.
to
That's the
do things,
core
right?
thing that we built was to make this easy for the people that were using these tools. At the end of the day, we want to
Mhm.
empower down in organizations to the people that are doing the work to be able to use these systems with ease. And the easiest way to do anything is just to ask a question in the language you speak of a tool that understands that language and can return very detailed, hyper contextualized answers to you as a byproduct of just asking a question in normal language. But we do some things to set that up. And I think this is like a really important point. We work on sort of this T cubed framework, which gives us like full cycle chain of cognition explainability. And that is from a traceability perspective, we assign unique identifiers to every node, every edge, and the relationships these systems have. And so we ID them, we semantically embed them, we enrich them, we understand temporal effects, when they start, when they stop, who was involved, where it happened,
Mhm.
geographic constraints. We can interpret, how, where, when. And as a byproduct of that, we can start to get to the whys and the hows. Like we can start to define these things in query quite easily. And the other thing that we really try to do and be effective with is making sure that we can really adhere to general data provenance standards. So we source things, we cite things, we understand where they come from, why they come from these places, when we got it, who was the last person to update these records. What does that mean for how that information is used? And when we do all of these things, we can contextualize these environments the way that we do. And it allows us to start breaking down this information environment just holistically in slicing and dicing just
Nice.
different components of it. So we can start to say, hey, I want to look at all my known entities and all the banking activities going from those entities to different pieces of this
Yes.
overall information puzzle. We can start to look at evidence at scale and say, like, we want to slice this up on different evidence types. We want to use geographic boundary conditions. We want to set temporal like designations on when we retrieve information. So all the stuff we do to prepare this environment allows us to contextualize this environment on query, which makes it easy for these systems to understand this information because we're not presenting it in rows and columns. We're presenting it in ways that is actually connective tissue, sort of in a 3D format. And whenever we do that, it makes it very easy for these systems to understand what we're asking, the information we provide it, and how to answer those questions. So all the stuff that we do in the background, labeling people, the connections between people and locations, the timelines associated to it,
Mhm.
are to enable that sort of natural language interface with these things and to make it easy on the people that are executing the work within the systems that we're deploying. This is a bit more of a back end view of the data model itself, the information environment, and just how these things are connected. But the user interface that we build, I'll pull up here quickly, is really intuitive as well. I mean, we're essentially building an information environment out to answer questions like this. This is a great question because if you know about the oil and gas industry, this question is insanely hard to answer correctly. This question was asked of us as a company. Can you help me understand how to optimize my produced water disposal activities, reduce my total expense associated to that, and then identify any profit increase opportunities I have within the structure of the network of information I provided you? Well, like if you know anything about oil and gas, you need about 10 real different segments of the business to understand how to answer that question correctly.
Yeah.
So there's a lot of functional representation, whether it's from the Wells organization, in the midstream asset base within this company, how these things have performed in the past. What does that mean for what they're regulated to and from? What are they authorized to do? What are the contracts associated to each one of these things? What are our activities forecast moving forward? What does that mean for our produced water forecast? What does that mean for our historic put away? Like, are we planning to something that we've never been able to accomplish before? What do our permits say about how we operate? What are our cost of operating? To answer that question, you need all of those pieces of information, or you can't answer it correctly. And so, what we really built is a system that allows us to answer really hard questions in really simple ways. Like asking that
Yeah.
question in that way in the past is impossible to get a right answer on. And what we built is a system that cross references all of this information, pulls it based on the way that we ask that question, and creates really explainable outcomes. Does that make sense?
Yeah, that is so freaking cool. Like just this stuff people are creating now with this technology just amazes me every day. I got like 3 tangents I want to go down, and I know we're running out
Cool.
of time, but like I'm curious if we could hit them.
Yeah.
All right. So first of all, all right. So like the first thing that comes to mind is like you just asked this question. It takes a whole team of people typically to do this, write this report. What's y'all's take on what happens to our place in the workforce, the functions we are doing as humans versus what we can, deploy to AI tools like this, especially the more it gets integrated in with our
Yeah.
data. Any just thoughts more broadly on that?
Yeah, we both definitely have thoughts on this. I'll give you sort of a general thing. Like our mission as a company is to discover a better way. Our
Mm,
vision for this company is that we
I
can
love
build
that.
a world where machines and people make smarter decisions together. Like, we're not working on replacement theory here. We're trying to empower the
Mhm.
people that are doing the work to do more work more efficiently, more effectively every day. Now, that's going to have some knock on effect as you start to proliferate this technology and these environments. But we're really trying to do it in a way that empowers people to do the jobs they already have more effectively. And so, like, we're not trying to replace people. Our old professor at Harvard has this great quote that says AI is not going to replace people, but people with AI are going to replace people without it. And I think that's the truth, right? It's about how can you get smart in using these tools and building agile systems that allow you to sort of plug different information in at any point in time and sort of 10x your capacity as a doer within the structure of the organizations that you already operate in. And that's our goal at the end of the day. We're not trying to replace anybody. We're trying to make it easier for the people that are there to do the things that they need to do at a really high efficacy rate. Dan, I'll turn it over to you. I know you have your own thoughts on this stuff, but please.
No, it's a really interesting question. And I've, I have a similar perspective where, technology it evolves what people do. If you go back to, I think a good example is kind of the horse and buggy versus the automobile. There was some change, but the automobile became this enormous industry employing hundreds of thousands, if not millions of people that wouldn't have existed if you didn't have that shift from the horse and buggy and you think of like traditional Sherlock Holmes type, Victorian era to what we have today with all the different automobiles and just all the industry that's built around them. What we're seeing here is with this type of technology, with AI, and everyone's talking about agents and all these different tools, it is shifting how you do work. Programming, the actual software developer writing code is going to be a really interesting one to follow because if you're using a tool like a Cursor or a GitHub Copilot, it is automating a lot of the steps of building software, writing software, debugging software. But the Cursor team did a really good interview maybe 3 or 4 months ago where they said they want to make coding fun again. And so you're taking away a lot of the debugging and the searching Stack Overflow, where instead
Yeah.
I can just find the issue that's being debugged and have it fixed. Or with tab complete, hey, I made one change on the code. It can populate that through 20 other instances in my code. And so I really do think for at least the near term, it's going to be a shift in work And for many cases, it's going to make the work better and easier to do. That's not to say that we shouldn't be very aware and very supportive of rules that might get changed, but that's not what we're focusing on here. We're really trying to bring the capabilities of a graph and AI and reliable AI to end users, intelligence analysts, or other data analysts who are already doing this type of work. We're just making them more efficient and more capable in doing that specific work.
Like
Yeah, no,
I
that's
do.
good. And
Sorry,
you go
just
ahead,
one
Jeff.
last follow up there that I think is so important. We're working with the FBI now. We won't get into the details of
Mhm.
what we're doing, but the change in how they query the system and the depth that they can get and the fidelity that they can get out of something that we're doing versus traditional systems like Palantir, Scale AI, and some other companies is significant. It's non trivial. The ability to understand the connective tissue at depth allows you to answer questions with more certainty and more predictability. And that's kind of the crux of the system that we built. It's like raising the level of interrogation with ease. It just gets you to a deeper level of understanding of the environment you're operating in, which should give you better results ultimately at the end of the day.
Yeah, and I'm curious, and you were just sitting on Cursor as an example there, Dan. I'm curious, like how y'all are using AI in your business. We obviously see it in the product, but how are you using it in the business? I'm on the side, like I'm not a software developer. I understand how it works, databases, front and back, and all that
Mhm.
kind of stuff. But I've now gone on this kind of like journey to building stuff, and it's like this hugely empowering, democratizing moment to where I can work with AI. And I've gotten to the stage where I'm having it work up front in the requirements phase. And then
Mhm.
Mhm.
I'm getting into, okay, now let's plan this out. Where do we want to start? Because you don't want to zero shot it. You want to kind of do it iteratively. And then you're just building upon it from there. But curious, like any, like, you don't have to go through a laundry list, but is there like one or two use cases where you're using
Yeah.
AI in the business specifically that's neat?
Well, Dan's doing a lot more of it than I am. I can tell you the use case that I use it for most consistently is checking the things that I write because I'm a product of the Texas public school
Yeah.
system. And I got to tell you, this thing is fantastic at helping me make sure I don't make mistakes in writing. So, it's trivial stuff like that that is really, really useful. Dan will talk to you about sort of the technical merits of it and the things that you can use it for. But for me, it's about making my life a little bit easier for the things that I don't do great at.
Yeah, and I think big picture, it's a how AI should be used today as an assistant with a human as part of the process. And I think anything you do has that foundation. And so, from a developer perspective, yeah, we have tools like Cursor or Copilot to help, especially with debugging and just finding issues or just accelerating the process of developing a software application. Our developers are using those tools. I like using tools like Perplexity for research that is grounded, with in facts. Um, and then, yeah, like I know, I do a lot of writing on LinkedIn and kind of putting a lot of content out there. I write all of my own content, but I will use it for idea generation
Yeah.
or image generation, or even, when we're working on a new feature in the product or building out a new use, excuse me, a case, using it as a brainstorming partner.
Mhm.
We're doing a lot of work right now with all source intelligence and cybersecurity. Another core graph use case that we're building a demo for is secure supply chain and logistics. And,
Yeah.
I'm not an expert in that area, but I can describe what I want to convey and how I'm going to use it. And it can help me brainstorm what should the demo be? What should the
That's great.
narrative be? And what should we kind
Yeah.
of build around to show the features of the graph as well as have an engaging story. So really anything, but as long as it is that, as an assistant with a human in the process and, making sure you have the reliable output and you can either double check the response or as we do with our platform, have everything cited to a piece of data.
And that's
Yeah.
half the battle is knowing ways you can use the tool, and there's
Yeah.
no better way to learn than just starting to use it. And last question, I promise I'll let y'all go. Like
Yeah.
we've hit this crazy moment, and by the time this launches, who knows
Yeah.
where the heck we'll be. But DeepSeek just got launched. No, well, it's actually been out. The model's been out, but there was this huge reaction in the market where you got over $1 trillion just eviscerated in a day, right? and it's their R1 model. It's, the reports are they trained it in like under $6 million versus hundreds of millions you have with AI. Inference cost is fractionally cheaper
Mhm.
as well. I'd be remiss if I didn't ask the guys with lots of government background and
Yeah.
experience, just like, what's your thoughts on it? Either, from a US perspective, more broadly from the industry and AI, just, yeah, curious what
Yeah.
your thoughts are.
We'll have, I think, some different perspectives on this, just given our backgrounds. But like for me, from a business perspective, I've looked at large language models, at least foundational models, and how you interact with these models as a race to commoditization. Like we're getting to a
Yeah.
point; it's a race to the bottom. Context windows are going to get bigger. Your ability to interact with these things is going to get wider and more prolific, and the cost associated is going to go down. Like that is just where we're headed right now. And I think Andrew Ng had a comment yesterday, which I thought was a pretty accurate representation of an understanding of what happened. And it said, today's DeepSeek sell off in the stock market attributed to DeepSeek's version 3 R1 disrupting the sort of norms within the tech ecosystem is another sign that the application layer is the right place to be. It's a
Oh,
great
yeah.
place to be
Mhm.
because the foundation model layer is hyper competitive and is full on racing towards commoditization. And that's great for people that are building applications. That's great for people that are building platforms. And so, you know, like that was always going to be a race to commoditization. It just so happens that
Mhm.
something happened that influences it in a very, very tangible way quite quickly. The depth of differential between what was normal commoditized and commercialized models at this point versus what you could get, at least in terms of cost and performance, was such a departure from what we've seen from some of these companies that it really sent shockwaves through the industry because, and
Yeah.
I'll just say this in general, from a business perspective, we had Project Stargate announced a couple of days ago while I was in
Yeah.
DC, and that's a $500 billion program of work to like build data centers around these large scale infrastructure compute facilities. And while I don't think that changes like super tangibly in a very short period of time, we were always going to get to the point where we were going to have personalized
Mhm.
LLMs or small language models running at scale on PCs that people were going to use in a disconnected capacity. This just might accelerate our path towards that. That's my
And
perspective. Dan, any other
well,
thoughts?
just one point before,
Yeah.
because Dan, I do want to get your take, but I think the other piece is this, like, Jevons paradox at play, kind of like economics here. When stuff gets cheaper, commoditized, paradoxically, it increases consumption of the
It
thing.
does.
And it's not, training isn't the only thing where the energy and GPUs are needed. You need it on the inference side as well. And I think once these AI
100%.
use cases get, um, you can do more things. More things become viable, which means you're gonna need a lot of power on the inference side. So, like in my mind, NVIDIA CEO is probably sitting there saying, "No, I'm good." We're
Yeah.
still gonna,
Oh,
yeah,
I'm with you. I got a call yesterday from the state of Louisiana saying, not saying who, but what does it mean for our future data center growth? And I said,
yeah,
nothing. Like as you commoditize exactly the point that you just made, it
yeah,
widens the user base, which means that the use stays roughly the same as you scale, like it or
yeah,
grows more. And so like we're still going to need data centers, but the personalization of this stuff is going to be pushed down quite quickly. And
yeah.
so
It's gonna be
I
cool.
think you nailed that completely. Sorry, Dan. I don't mean to step all over
Yeah,
you.
Dan, you got the final word. Give us your last hot take before we
I
wrap it
think
up.
you really hit on it, and this really won't be a hot take, but if we are really 2, 3 years in, I know that some of the early GPT technology has been around longer, but a year and change ago, we were talking about mixture of experts. And before that, it was, ChatGPT had just been released and
Mhm.
we were dealing with 2000 or 4000 token context windows. And so I think in the early stages, this is just one more advancement in the technology. And it's going to be copied rapidly. I'm sure Llama and Google and everyone else, they're going to have their own versions of this. They're going to be testing it out, improving it. And I think that actually is going to also emphasize the importance of open source in addition to the proprietary models. The fact that they
Yeah.
released this, both the model, the weights, and the paper that goes with it will mean this approach, it it looks very promising. It probably still needs to be proven out a little bit more. There's going to be areas where it gets improved. But a year from now, it's going to be there. It could be the standard. It could not be the standard. We really don't know yet. But the big picture is it's just one more step forward in the technology. And to your point, Jensen and NVIDIA, like everyone's saying we're good because this is just going to make it more accessible and more usable more broadly. And we're still going to be going down this path.
Nice. Yeah, you rounded it out perfectly, bringing in the open source take there as well. But Jon and Dan, thanks for jumping on, talking some AI. Where can folks find you? Where can they learn more about data²? Jon, go first.
Yeah. LinkedIn, our handle is at data2us, and our website, data2.ai. Those are the two places you can find us the most. Both Dan and I are pretty prolific on the LinkedIn front, so you can look us up individually, at Jon Brewton and at Daniel Bukowski. That's, I think, Dan, you probably have some other things you want to hit, but that's the broader ones.
No, that's it. Yeah. The website, LinkedIn, and there's some great demos of the software on YouTube. And
Oh
especially
yeah.
whether through a website or LinkedIn, if you want to reach out and learn more, just send us a message and we'd be happy to talk as well.
Yeah, we'll drop some of those in the show notes. I got some cool demos out there on YouTube and whatnot. And your dog agrees in the background, it sounds like too.
Either the mail just showed up or it's dinner time or both.
Yeah, nice. All right, guys, have a good one. Thanks for listening to the Talking AI podcast. If you enjoyed the show, give us a follow or subscribe on your favorite podcast platform. And don't forget to leave us a review. We love those. For more info on Talking AI, visit talkingaipodcast.com.